what will be the force exerted, what will be the force exerted pulley, by the pulley on supporting rod, on supporting rod, right? What will be the force exerted by the pulley on supporting rod? Yes. 4 kg and 8 kg connected, 4 kg is resting on a smooth surface, 8 kg is not having any contact with the vertical side of this table, you can consider it like, okay. Say 4 kg is normally the vertical forces are getting balanced, no doubt about it. But there must be some unbalanced force as a tension T, right? So that T will act here and 8 kg will have its weight acting 8 g downward. Being it is a smooth surface for 4 kg, so the rightward tension force, whatever it is, that can pull the 4 kg mass in the rightward direction. So as a result of it, I can expect this to be gaining some acceleration this way, and being a connected body, this too will go vertically downward. So that means I can write down T is giving the accelerated motion 4A, and 8g minus T, that is equal to 8 into A as the second equation. Adding them together, T gets cancelled out, 8g, that is equal to 12A. So A is equal to 8g by 12. Yes, it is 2g by 3. So now, once this acceleration is known, you can get the value of T. So this implies that T will be equal to how much? It is 4 into A. So 4 into 2/3 of g, right? So it is 8g by 3. Yes or no? Tension force is coming 8g by 3. If the tension force is 8g by 3, then I have asked about the force exerted by the pulley on the supporting rod. So diagram is like this. So pulley is having no mass at all. Pulley is given no mass for itself. So how then pulley can exert force? Because these are the two tension forces that of the string that will compress the pulley along the supporting rod, right? So geometrically, it has to be in geometrical angle, symmetrically 45 degree. So that means the resolution of T along this direction, right, for this two T will be going this way. These two components will be getting cancelled out, and you can write down this is 2T sine 45 degree, right? So 1 by root 2, that is root 2 into T. So that means the supporting force, right, supporting force will be root 2 into T, that is 80 by 3 Newton. Is that clear? So let this is be the one block connected with the pulley, okay, going this way, this is connected this way, and one block is suppose, this is a very common relation, it is going this way. So let this is a 4 kg mass, this is suppose a 2 kg mass, this is given an angle of 30 degree, right? If this is going down with an acceleration fa, what will be the acceleration of this one? This is a very simple question, but this relation is quite useful. Just a minute, A1 is equal to 2 by root 3 into A. If a question is asked like this, let this is the block A, this is the block B, this is the block C, right? This one is going this way A1, this is going this way A2, okay. These are the respective accelerations suggested, right? And let this is going A3 meter per second square in the downward direction. So what will be the relation between A1, A2 and A3? See, first of all, tell me under which condition are these two pulleys changing their position? So that means these two pulleys, this one is fixed, this one is also fixed, right? So far as per the diagram suggests, this is going downward. So that means this portion is definitely increasing. So we know that whatever, if the block C is going downward, so definitely this pulley attached with the block C, that is also going downward. So that means this part and this part, the sum of this two taken. If I suppose this is taken, this is x, this is y, this is x1, this is x2, right? And this part is suppose x3. So as block C is going downward, so definitely x3 is increasing. No, I mean not only A1 is decreasing, A1 is decreasing, A2 is increasing, but the fact is that in spite of the movement of A1 need to be more than the movement of A2. How and why? Because if suppose in one time, suppose this is goes forward by, for example, 2 meter, and suppose at the same time this goes by 3 meter, so then what will happen? Total, if this side it is decreasing by 2 meter, this side is increasing by 3 meter. So gain is more than loss. So in that case, C will be, that means here you should understand, as the C is going downward, that is only possible if A1 is more than A2. Had it been given C, had it been given this C going upward, right, then it could have made the sense that A2 is definitely greater than A1. So that's why the total released will be A1 minus A2, and whatever the released part, right, that released part will be, the twice of that released part will be C3. I mean that A3. Because whatever the block C will move, it will pull equal on both sides. So total free portion of the string will be twice of the movement of this. So total movement is, total change or released length will be A1 minus A2. That will be twice of A3. Got it? So that will be the relation. Had it been given A3 is going upward, then this relation could have been A2 minus A1 is equal to twice of A3. Is that clear?